and misused in the programming world in Python. So during this talk, I'm assuming that you know how for loops work in Python. I'm also assuming that you're not already a fan of list comprehensions and generator expressions. I'm hoping to make you a fan of both of these by the end of the talk. Here, let me put a link to, for audience members who want the link to this chat, I'm going to put it in the chat itself here. The link is crowdcast.io/e/pythondaymx. So before we get started, let's start with some definitions. I'm going to use all of these words throughout this talk. An iterable is anything that you can iterate over. So anything that you can loop over with a for loop is an iterable. Lists are iterables, dictionaries are iterables, sets are iterables, strings are iterables. Lots of things in Python are iterables. A list comprehension is a special syntax for making a new list from any iterable. A generator is a lazy iterable. Generators can be paused and they can restart themselves repeatedly as you loop over them. And a generator expression is a special syntax for making a generator. So I'll be discussing all of those terms, but the term we're primarily focused on is list comprehensions. List comprehensions do not solve a new problem. They're a special purpose tool for solving a problem we're already able to solve with for loops, turning one list into another list. Let's talk about for loops before we dive into comprehensions. Python's for allows us to loop over any iterable and do things with each item as we loop. So we can put if statements in a for loop, we can put print functions, we can put pretty much any code that we want inside of a for loop. This for loop makes a new list. Making one list from another list is a really common thing to do in Python, even more common than in many other programming languages. Turning old lists into new lists is common in other languages, but it is particularly common in Python. I want to talk about why making new lists from old lists is particularly common in Python. So I want to do a little bit of an aside here. Before I do that, I want to make sure that audio visual is good and that we're still good to go on the talk here. Everyone still can hear me? I guess if someone could type something on the keyboard there because I have you all on mute. Well, I can still hear in the room. All right, Kojo can still hear and see me. So I'm assuming everyone in the audience in Mexico City can as well. All right, I'm not getting any visual cue there, so I'm going to keep going here. So assigning to a variable in Python doesn't copy anything. Variables in Python are not buckets containing objects. Variables are simply references to objects. This can really trip up new Python programmers. So in Python, we tend to copy old lists to new lists because mutating lists is often a bad idea. When we modify a list, every other variable that points to that same list will also seem to change. So instead in Python, we copy old lists to new lists. So that's the reason list comprehensions are so common in Python. Copying old lists to new lists is essential because of this weird way that variables work. So that might have been a little bit confusing, but the thing that I want to drive home here is not, I don't need you to understand why we use list comprehensions. I want you to understand how they work. So turning old lists into new lists is really common in Python. It's so common that Python developers, the Python core developers, have added a special syntax just for turning one list into another list. This special syntax is called a list comprehension. So this list comprehension here is equivalent to the for loop that I just showed you. This list comprehension is extremely information dense. We've condensed what was, I believe, 4 lines of code into 1 line here. So let's break down our for loop and our comprehension and see how they compare. Here I've highlighted 5 things in this for loop. The variable name for our new list is in green. The square brackets that make our list are in dark red. The looping logic is in purple. The condition is in bright red. And the item that we're appending every time that we loop is in blue. Here are the same items highlighted in our comprehension. Notice that our comprehension contains pretty much the same information as our for loop, except that we aren't repeating the variable names and we don't have to type append. Loops and list comprehensions are so similar that you can actually copy paste your way from a for loop to a comprehension. Let me show you how to do that. So when copy pasting away from a for loop to a comprehension, first we copy the assignment. Then we copy the thing that we're appending. After that, we copy the looping logic, and then lastly, we copy the condition in our loop. After we've copy pasted our way from a for loop to a comprehension, we have an identical loop that does the same thing as our for loop that is just in the format of a comprehension. So we just need to copy all of those elements from our loop in those square brackets to make up a list comprehension. So here I've highlighted the same things that I highlighted before, but this for loop is generic. It's a blueprint of sorts for how we can go about making sure that our for loop can be copy pasted into a comprehension. As long as you can figure out a way to write your for loop in this format, you can always copy paste your way from a for loop to a comprehension. So I've shown you how to build up a list comprehension from a for loop. To copy paste your way from this for loop to this comprehension, let's talk about the readability of these things. That's a common complaint with list comprehensions in Python. So readability is probably the most common complaint with list comprehensions. They tend to be a lot more compact than for loops. Let's talk about that fact. So comprehensions are often written all on one line of code. That can make comprehensions hard to read. This comprehension has less unnecessary information than that for loop, but it also has a lot less white space. We've compressed what was 3 lines of code into 1 line of code. Comprehensions have 3 parts: the operation, the loop, and the condition. There's no reason that all 3 of those parts have to be written on 1 line of code. In Python, whenever you have an open bracket, an open brace, or an open parenthesis, you can insert line breaks to break 1 line of code over multiple lines. Breaking comprehensions into 3 lines can make them much more readable. In fact, I would say that breaking up a comprehension over multiple lines almost always improves readability. So I would recommend writing the large majority of your list comprehensions over multiple lines of code. Note that this multi-line list comprehension we've ended up with here has not saved us any lines of code. In fact, we've gone from 4 lines of code in our for loop to 5 lines of code in our list comprehension. List comprehensions are not about saving lines of code. List comprehensions are for making our code more descriptive and more readable. When a reader looks at our for loop, it's obvious that we're looping, but it may not be immediately obvious why we're looping in this for loop. When a reader looks at our comprehension, it should be immediately obvious that we're creating one list from another list. When we use a list comprehension, we're being more specific with the intent of our code. We're not just looping, we're making one list out of another list. So I've glossed over a few important details in the world of list comprehensions. I've only shown you one type of comprehension here. So let's look at a few other ways that you can make list comprehensions and comprehensions in general in Python. The whole time so far, I've been showing you a list comprehension with a condition. These list comprehensions filter out items that don't match a certain condition. So you can also write list comprehensions without any filtering at all. You can remove this if statement and write your comprehension like this. Here we're not filtering down anything at all in our for loop or our comprehension. We're simply changing each item. So our for loop doesn't have an if statement and our list comprehension doesn't have a condition. Note that you can still copy paste your way from that for loop to this comprehension here. List comprehensions can be used for filtering, for mapping, or for both. We were using it for filtering so far, and maybe for mapping and filtering. Here we're just using it for mapping old values to new values. You can also put multiple for loops in a comprehension. Here we're looping into a list of lists and flattening it into a single list. Putting multiple for clauses in a comprehension can get a little bit complicated, so be careful about using this. If you're going to do this, make sure that you break up your comprehensions over multiple lines, because these things can be hard to read when they have lots of loops in them. Comprehensions aren't just limited to lists, though. You can also make set comprehensions. So just as list comprehensions build up lists, set comprehensions build up sets. Set comprehensions are functionally equivalent to this for loop here, where we're appending items to a new set over and over in our loop. Just the same way that list comprehensions are equivalent to appending items to a new list over and over in a loop. So set comprehensions build up sets the same way list comprehensions build up lists, and dictionary comprehensions build up dictionaries in the same way. So there's set comprehensions, there are dictionary comprehensions. List comprehensions make lists, set comprehensions make sets, dictionary comprehensions make dictionaries. Sets and dictionaries have a similar syntax in Python. Likewise, dictionary comprehensions have a similar syntax to set comprehensions. Dictionary comprehensions use those curly braces the same way that set comprehensions do. But unlike set comprehensions, we need to put a colon in between our key value pairs in order to build up that dictionary. All right, so I've shown you list comprehensions. I've shown you a number of ways, different ways to make comprehensions, set, dictionary, and list comprehensions. I've shown you the syntax. I haven't really shown you too many different examples. We've been looking at some very limited examples here. So let's take a look at some hopefully slightly more realistic examples of list, set, and dictionary comprehensions. One of the simplest uses of list comprehensions is to make a new list from an old list while still modifying, or while slightly modifying, each element along the way. So here we are lowercasing each word in our words list as we loop over it, making this new lowercase words list. Notice that we're not filtering anything here. There's no condition at all. We're just modifying each of these words to make this new list. One use for dictionary comprehensions is to swap keys and values in a dictionary. So notice we're taking key and value and making it into value key. Dictionaries have to be, or dictionary keys have to be unique, but dictionary values do not have to be unique. So if any of the values in our dictionary are duplicates, we're going to get collisions when we do this operation. So you should probably only swap keys and values in dictionaries if your values happen to be unique. Here we're using a list comprehension to loop over digits in an integer. We're converting the integer to a string, then we're looping over the characters, then we are converting each of those characters back into an integer. So we start with the number 4,321, we end up with the list 4321. This example is a little bit silly, mostly because if we had a negative number, this would break because the negative sign is not a valid integer. But this example shows here that we can loop over characters in a string. So we can loop over pretty much anything with a comprehension and build up pretty much anything, as long as we end up with a list. Here we're using permutations from the itertools library to help us find anagrams of words, both invalid and valid ones. So itertools.permutations is being used to generate all permutations of the letters in a given word. So as we loop over this permutations object, we get a list of letters, and we are joining them back together with this string.join method. So we'll end up with a set of all anagrams of a given word. So this is a pretty complex example. We're doing a lot with very few lines of code here. Here we're also constructing a set, but we are filtering something. So we're counting the number of occurrences of each character in a string. And then we're making a set of only the characters that occur exactly once. So we're using collections.counter on a string, and then we're using a set comprehension to get unique letters from that counter object, characters that only have a count of 1. So we're building up a set of all the unique letters in a given string. So again, there's quite a lot going on here with very few lines of code. There's very little unnecessary information on this screen. In this example here, we're using a comprehension to loop through words and check whether each word is an anagram. Note that we're calling a function to do this because isAnagram is a lot more descriptive than a comparison of the sorted letters in 2 words. So we're using a list comprehension to filter down our words list to a new list of only words that are anagrams of our target word. So we're not changing our words at all here. We're just filtering them down to only words that are anagrams. This here isn't a comprehension yet. This is a for loop with a for loop inside it. We're building up a list of lists. That empty row, that empty new row on line 3 there, and the new row.append on the second to last line, that looks like something that we can actually copy paste into a comprehension. If you look at just those 3 lines, new row equals empty list, for n in row, new row.append, we could make that into a comprehension. Now notice that we have something at this point that also looks like we could make a comprehension out of it. We have negative matrix equals an empty list. For row and matrix, negative matrix.append. We could also copy paste this outer loop into a comprehension. So we've made a list comprehension inside of a list comprehension. Please only do this sparingly. Comprehensions inside of comprehensions don't always improve readability. In this case, I think it might actually have improved readability, but be cautious when making comprehensions into comprehensions, but know that you can. And make sure that you break these over multiple lines of code for readability. Here we're using comprehensions to build up sets of neighbors for Conway's Game of Life. If you haven't heard of Conway's Game of Life, you can look it up afterwards. It's an interesting programming game that has a large fan base around it. So we're filtering all living cells based on the number of living neighbors that they currently have. We're also filtering all dead cells based on the number of living neighbors that they currently have. The 2 filterings are different though. This isn't the entirety of Conway's Game of Life. It's a pretty big portion of it though. I think this is about 25% of my solution of Conway's Game of Life that I've made for some kind of programming challenge in the past. I also used generator expressions and set comprehensions in my solution. So we've seen examples of how to use list, set, and dictionary comprehensions here. Let's finally talk about generators. List comprehensions make lists. Set comprehensions make sets. Dictionary comprehensions make dictionaries. Generator comprehensions make generators. Except that they're not actually called generator comprehensions. They're called generator expressions. Why they're called generator expressions and not generator comprehensions, I don't know. If you say either term, generator comprehension or generator expression, people will know what you're talking about. So it doesn't really matter which term you use, but they are technically called generator expressions. You might be wondering what a generator is. You probably know what a list is and a dictionary is, and maybe what a set is. I'm not going to be able to go deep into what generators are during this talk because it's a complex topic and that could be an entire talk of its own. There's one thing that I want you to remember about generator expressions though. If you're writing a list comprehension and you're going to loop over your new list exactly once, you should write a generator expression instead. So I'm going to say that again. If you're making a list comprehension and you're only going to loop over the list that you're making one time, use a generator expression instead. All right, let's look at how generator expressions work. If you write a list comprehension and you change the square brackets to parentheses, you've made a generator expression. Generator expressions make generators the same way that list comprehensions make lists. Generators are strange objects. They're pretty weird. So let's take a look at some of the behavior, this weird behavior of generators. Generators don't know how many elements they have inside them. So they have no length. When you ask them for their length, they give you an error. You also can't index generators. You can't index them like you can with lists or tuples. The only thing that you can do with a generator is loop over it. But the second time that you loop over a generator, you will get nothing back. You can only loop over generators once. So generators are a little bit weird. This generator is squaring all numbers from 0 to 1 billion. Now, if I did this with a list, it could fill up my computer's RAM. It would probably take 8 gigs of RAM or so, and it could take a very long time. But this generator hasn't actually done any work at this point. No work will be done until we start looping over this generator object. Generators compute items as you loop. So at this point here, only the first 3 items have been computed in this generator. It hasn't computed all 1 billion items. Generators can be looped over just like lists, but they are lazy. They only compute values immediately before you provide them. So generators are lazy. They are also single use. They are one-time use only. The only thing that you can do with generators is loop over them, but you can only loop over them once. The second time you loop over a generator, it's empty. Generators are one-time use only. Once you've looped over a generator, it is exhausted. So generators are lazy and they are single use. They are lazy single use iterables. They don't do any work until you start looping over them, and once you've looped over them, they're exhausted. So to be on the safe side, you should loop over a generator as soon as humanly possible. Don't even make a variable to store them in, just loop. The sooner you loop over a generator, the less likely it is that you might accidentally loop over it twice. This is such a common thing to do in Python, to pass a generator directly into a function, that you can actually remove those redundant parentheses around generator expressions. This is probably the most common way to use generators in Python. Create it and loop over it right away. So you're probably still a little fuzzy on generators and generator expressions at this point, but hopefully you understand a little bit about them, and that you at least understand that you should create them and loop over them immediately. That is the time to use generator expressions. Now let's take a look at a couple examples of when you might use generator expressions in your code. Here we're looping over a list of words, transforming them, and adding them to a new list, and then joining them back together with spaces between them, with that last line, space.join. We could use a list comprehension for this, but the join method on strings accepts any iterable. So we don't necessarily need a list. We could actually copy paste our way into a generator expression. So here we've moved our list comprehension into the join call, and then we removed those square brackets to make a generator expression instead. We did this because we're looping over it only once. There's no reason to make a list when all we want to do is construct a string out of it afterwards. Here we're looping over numbers and summing up their squares. If we wanted to use Python's built-in sum function, we could refactor this code to make it look a little bit more like building up a list. Now this is silly because we're making a list just to loop over it once and sum it. But we can take this and copy paste our way into a generator expression. Here we end up with something that's more descriptive. We're summing up the squares of each of our numbers. So that one line of code, we've succinctly described what we're doing, which I think is superior to that first section that we started with there. So your code won't always look like something that is appending to a list over and over and can be easily copy pasted into a list comprehension or a generator expression. You can sometimes finagle your way into making something that looks like building up a list and copy paste your way into a generator expression though. Here's another example. We are looping over all numbers below a given candidate number and checking whether it has any factors. If the number is divisible by any number below it, we immediately return false because we know that it's not prime. It has a factor. Otherwise, at the very end, we return true because we didn't find any factors, so the number must be prime. If we wanted to use Python's built-in any function, we could refactor this code to use a list of true and false values. So here we're using not any on that last line to make sure this number has no divisors. We're building up a list of true false values and passing it to any there. The built-in any function in Python returns true as soon as it finds a truthy item as it loops. And if everything is false, it will return false. This strange divisibility list will allow us to copy paste our way into a generator expression. So this in-between state here, like before, is very odd. It's very strange that we're making a list just to loop over it once. But we can copy paste that into a generator expression. So this any function will return immediately when it hits a false condition, just like our for loop did before. So that first section of code and that third section of code are functionally equivalent. The last one returns false as soon as it finds a factor. Otherwise, it gets all the way to the end and returns true. Now, any is a little bit awkward to solve this problem because that not any is hard to read. Let's look at solving this with all. So we've got the same code we started with before, and we're going to use the all function here. So notice we don't have divisibility as our list, we have non-divisibility, and we've flipped the condition. Candidate modulo n equals 0 is now candidate modulo n does not equal 0. So we flipped that condition so that we could use all. Again, we can copy paste our way into a generator expression. If any one of these numbers returns false, then we know this number is not prime and all will immediately return false. So return all numbers that are not prime for n in range 2 candidate. These any and all functions were actually specially invented to be used alongside generator expressions in Python. So if you see any and all, it is probably a generator expression that is being used with that. Okay, I've gone through a lot of examples at this point. If you didn't retain any of that, you're welcome to go look back at those examples. I did want to get you a little bit of exposure with different ways to write comprehensions and generator expressions. But I also want to talk about when not to use these things. So we've looked at comprehensions, we've looked at generator expressions, we've seen how to copy paste our loops into comprehensions. But when exactly should we use comprehensions? Is there ever an inappropriate time to use them? Is there ever a time not to use a comprehension specifically? List comprehensions are only useful for turning one list into another. Do not use list comprehensions except for making lists. Comprehensions should only be used for the specific but common use case of turning one list into another list. Here, we are calling the print function in a comprehension. We end up creating a list of none values while we printed things out. We don't really care about those none values in that list. All we care about is the side effect here. We care about the printing. Do not call print in a comprehension. In fact, don't put any side effects in a comprehension, even if you are making a list. List comprehensions should only be used for turning one list into another, not for printing. Here we're looping over a list of tuples and making a dictionary out of them. You might think that this would be a good opportunity to use a dictionary comprehension. It looks like something we could copy paste into a dictionary comprehension. But this isn't the best way to turn a list of tuples into a dictionary. The Pythonic way to turn a list of tuples into a dictionary is to use the dict constructor. The dict constructor is specially designed for exactly this task. There's no reason to reinvent the wheel by doing this ourselves manually. The dict constructor does this for us. So this is another inappropriate time to use a comprehension. In this code, we're looping over lines in a file and building up a list of all of the lines. Whenever you see a comprehension that does no filtering and no modification at all, this should be a red flag. We have a comprehension that looks like X for X in something, line for line in my file. The list constructor is usually the most Pythonic way to make an iterable into a list. But this isn't the only way to do this. In this particular case, files also have a readlines method, which might be more Pythonic or might be less Pythonic, depending on who you ask. So when building a dictionary, if you're not changing anything, use the dict constructor. When building up a new list, if you're not changing anything, use the list constructor. Just as there are sometimes simpler ways to do things than a for loop, there are also sometimes simpler ways to do things than a comprehension. I'd like to recap what we've talked about so far and provide you with a few slides that can hopefully act as a cheat sheet of sorts to help you figure out when, where, and how to use comprehensions and generator expressions in your own code. I will share these slides afterwards so you can review this later. So this is a for loop that loops over a list of items, does an operation, and appends the result to a new list. Whenever you have a for loop written in this format, you can copy-paste your way into a comprehension. This list comprehension is equivalent to that for loop. This is a for loop that loops over a list of items, checks a condition, does an operation, and appends a new item to this new list every time that that condition is true. Whenever you have a for loop written in this format, you can also copy-paste your way into a comprehension. This comprehension is equivalent to that for loop. So you can use comprehensions for mapping. You can also use them for filtering or for mapping and filtering. This is a loop that checks a condition and builds up a dictionary of key value pairs. This loop is equivalent to this comprehension. You can almost always copy-paste your way from a building up a dictionary to making a dictionary comprehension. The one thing that you have to be aware of is that key value needs to be a key colon value. So not quite copy-pasting, but close to it. This is a nested for loop that builds up a new list. We're taking a list of lists and converting it to a flattened list. Whenever you have code in this format, you can copy-paste your way into a comprehension. So this comprehension here is equivalent to that for loop. We're taking a list of lists and flattening it into a shallow list. If you're making a new list from an old list without filtering or changing anything at all, you shouldn't use a list comprehension. You should use the list constructor. The list constructor loops over whatever we give it and builds up a new list out of it. It's simplistic, but if the simple case is all that we need, that's what we should use. If you're making a list and immediately looping over it, you should consider copy-pasting your way into a generator expression. Generator expressions look like list comprehensions, but they're lazy. Generators don't do any work until you start looping over them. So we're getting the benefit here of not having to create an unnecessary list just to loop over at one time. I want you to remember that you can use list comprehensions for turning one iterable into a new list. You can use set and dictionary comprehensions for turning an old iterable into a new set or a new dictionary. You can copy paste your way from a for loop to a comprehension. And if you ever find yourself making a new list just to loop over it once, consider using a generator expression instead of a list comprehension. Also remember that you can break up your comprehensions and your generator expressions over multiple lines to improve the readability of your code. Thank you. If you have any questions, I'm going to unmute the video now. I can figure out where it went on my screen. So I guess you can scroll down below the video to ask questions. Otherwise, folks are welcome to come up to the camera maybe. I don't know how you want to do it. We didn't really talk about that. I'm happy to also bring up a live terminal window and answer questions that way if you'd like. Okay. I see some questions below the video. Do you mind if I answer those? Okay. Kojo asks, are comprehensions unique to Python or are they in other languages? Comprehensions are not unique to Python, but they are unique in that there are other programming languages that use them, but there's not many. So I'm going to show you an example here. I can screen share. So in Haskell, comprehensions actually look like this. N such that N is an element of the real numbers. So this is a comprehension in Haskell, whereas in Python, we've made this N for N in some list. So most languages do not have comprehensions, but Haskell, I believe, is where Python stole them from. Lorena asks, adding on to Kojo's question, could you tell us about any performance boost we might see in terms of Big O? I usually avoid this question when I'm teaching about comprehensions because you shouldn't use comprehensions for their performance gain. So if one of them is slower or faster, if a for loop or a comprehension is faster, it's probably the comprehension because the compiler can optimize for that special syntax. But I wouldn't rely on comprehensions for performance. I would use them only for readability. So I actually can't tell you any performance boost. In terms of Big O, I would guess that there's no performance boost. In terms of minor, non-complex computational complexity boost, there might be some. Lorena also asks, repetition, repetition, repetition. Can you tell us why generators can't be looped over twice? Namely, what does lazy mean? So if you have an infinite list, as we loop over this, we have an infinite list. I'll actually call this numbers. If we say n squared for n in numbers, if we start looping over this, Python is consuming numbers as we go. And there is absolutely no reset button. So the key here is that they can't be looped over twice because there's no such thing as a reset. It's kind of like if you have a lap counter, you're running around the track, keeping track of your laps, and the lap counter is broken in that it doesn't have a reset button. You have to throw it out at the end. So I don't have a good reason for that outside of if you want to look into why that is the case, iterators, iterators, if I could spell here. Iterators are the thing to look up. They are the reason. I thought I was in Python 2 there for a moment. I've been teaching Python 2 a lot recently. Iterators are the reason that you cannot reset a generator expression because a generator is an iterator, and iterators are the way for loops work under the hood in Python. Another question here from a Python user. Does the comprehension have an advantage of CPU and or memory usage versus normal Python functions, or is this depends on the problem you're solving? I can't really answer that. I would look up on Stack Overflow if there's an advantage. I would guess the advantage is very, very minimal, if there is any advantage at all. So I would not rely on comprehensions for their performance gains. I would rely on them for their readability. Kojo's question, when should I use a comprehension instead of a loop? I think you already answered this in your talk. Yeah, so to use a comprehension instead of a loop, it's whenever you are appending, whenever you're building up a new list. So if you have something that looks like this, new list equals something, you say for n in numbers, new list.append n squared, and when you're modifying something there, this is the time to use a comprehension. Okay, that's all the questions below the video. If anyone has questions in the room, I'd love to answer.
I think we're great here.
Okay.
Thank you very much.
Thank you. It was. Bye. If anyone has questions, feel free to tweet me. My Twitter handle is this. See you.
Thank you.
Thank you.
Bueno, dentro de poco vamos a tener así como que dar la comida súper rápido.